In section 4.1, we are going to talk about reasoning and conditional statements. And the first kind of reasoning we're going to talk about is inductive reasoning. The definition of inductive reasoning is making conclusions based on observations. That is our key word right here, based on observations. Another word that we're going to be using is conjecture. And a conjecture is similar to a hypothesis in science, where you are going to try and determine what is going to happen next. So let's look at some examples. Our first example says make a conjecture about the next term in each sequence and then find the term. So in our first example, our conjecture, we want to determine what is happening to this sequence. So if we look at 160 to negative 180, I'm dividing 160 by negative 2. That gives me 80. If I divide by negative 2 again, that gives me 40. Divide by negative 2 again, gives me negative 20, all the way through. So my conjecture here is that I'm dividing by a negative 2. Once I have my conjecture, I can determine what my next term is going to be. So if I look at my last term, 10, and I divide that again by negative 2, my next term is going to be negative 5. Okay, so example number 2 is a similar process. Let's look at our terms and see what the pattern is, or our conjecture is going to be. So from 20 to 16, it looks like I'm subtracting 4. Then from 16 to 11, I'm subtracting 5. So I'm going to write these above here. Subtract 4, then subtract 5. From 11 to 5, I'm subtracting 6, then 7, then minus 8, etc. So my conjecture here is that I'm subtracting and I'm subtracting by a pattern. So I start with minus 4, minus 5, minus 6, etc. That makes my next term, if the last thing I did was subtract by 8, I'm going to subtract 9, and that gives me negative 10 minus 9 is negative 19. Okay, in our next example, we can also have a sequence with shapes instead of numbers. So if I draw out a series of shapes.
What do you want to say?
Here I have a triangle, a square, and a pentagon. So in order to find the next term in my sequence, I have 3 sides on this shape, 4 sides on this shape, 5 sides on this shape. So my next term in this series is going to have 6 sides. My conjecture is that I add 1 side each time. Okay, let's look at an example with some fractions next. So the easiest thing to do when comparing fractions is first find a common denominator for all of our fractions and then rewrite them all using that common denominator. So if we look at all the denominators, we have 6, 3, and 2. So the common denominator for all of those numbers would be 6. So if I want to rewrite this sequence using only common denominator of 6, my first one's going to stay the same, 1/6. Then if I want to change this 1/3, I need to multiply the top and bottom by 2. When I do that, I get 2 over 6. Then for 1/2, I got to multiply the top and bottom by 3 to get 6 on the bottom. So I get 3 over 6. Remember then, we're not changing the value of that fraction. 3 over 6 is still 1/2, but it just has a 6 on the bottom of our fraction. Okay, 2/3. Again, I need to multiply by that by 2 to get that 6 on the bottom. So I get 4/6. Then 5/6 is going to stay the same. 1, I can write that as 6 over 6. And finally 7/6. So all I did was rewrite this sequence with a common denominator of 6. Now I can see clearly that as I go up each term, I'm adding 1/6 each time. So my conjecture is add 1/6. So if that's my conjecture, I can find my next term. If I add 1/6 to 7/6, I get 8/6, and that simplifies to 4/3. Okay, let's move on to the next example. Make a conjecture based on the given information and draw a figure to illustrate your conjecture. Okay, each side of a square measures 3 feet. So if I draw that, I would have a square where each side is 3 feet. Now, one of the answers I could give is if I know the sides of my square, I could find the area. So I'm trying to come up with some new piece of information depending on what they told me. So if I know each side is 3 feet, my answer here, my conjecture, would be that the area is equal to length times width, which in this case is 3 times 3, which is 9. Another example of a conjecture I could have made, instead of finding the area of a square, I could have said the perimeter is all 4 of my sides added up. That would be a new piece of information that I got from the given information. So that would be 3 plus 3 plus 3 plus 3 is 12 feet. So either answer would work. Okay, let's try the next one. Okay, this one right here doesn't have our information on it, so I'm going to write that in, and you go ahead and do the same thing. Our information for this example is that angle 1 and angle 2 are vertical angles. Okay, so if angle 1 and angle 2 are vertical angles, that means that I have some kind of x with angle 1 and angle 2 straight across from each other. So if I'm making a conjecture, I want to say some other piece of information that is true from that given information. I could say that angle 1 and angle 2 are congruent. If I'm told they're vertical, then I also know that they are congruent. Okay, our next topic that we're going to look at is counterexamples. And a counterexample is an example that you could give to prove that a statement is false. So let's look at an example. If we were given that angle 1 and angle 2 are adjacent, so that means that they are next to each other, my conjecture is that angle 1 and angle 2 form a linear pair. So I want to give an example where angle 1 and angle 2 are adjacent, but if I'm trying to give a counterexample to show that this conjecture right here is false. I want to draw a picture where they are adjacent and not a linear pair. So if I drew this diagram right here, angle 1 and angle 2, they are adjacent, like in the given information, but they do not form a linear pair. So this example right here is my counterexample. Okay, let's look at another example down here. Determine whether each conjecture is true or false and give a counterexample for any false conjecture. So if we have given information, the sides of a quadrilateral are 3 inches long. Okay, so if I were to draw a quadrilateral, all 3 inches, the quadrilateral's perimeter is 12 inches. Well, I could draw a quadrilateral like this, or I could draw a diagonal like this, but no matter how I draw it, all 3 sides are going to be 3. And that means the perimeter has to be 12. So this conjecture right here is true. There is no example that I could give that would show that it was false. Our next type of reasoning is called deductive reasoning, and this is making conclusions based on facts. So our other one was based on observations. This one is based on facts. Deductive reasoning is used to prove statements in mathematics. And when we prove statements, they all must be justified by either a definition, a property, a postulate, or a theorem. And we'll get into some examples of those in a few minutes. Another term that we are going to be using is called conditional statements, and an example of a conditional statement is an if-then statement. So this is an example here. If 3 points are on the same line, then they are collinear. So it is some kind of if-then statement. Okay? Then we also have an example of a conditional statement here with a hypothesis. So as the hypothesis is our if part. If 3 points are on the same line, then our conclusion is that they are collinear. So that's another example of how to break up a conditional statement into your hypothesis piece and your conclusion piece. Okay, sometimes not all conditional statements are written in this if-then form. So if we have a statement like this, adjacent angles have a common vertex, and we want to change that to the if-then form, this is how we do it right here. If 2 angles are adjacent, then they have a common vertex. So we are separating the original statement where the verb comes in the sentence. Okay? It'll make sense as you practice it more too. Okay, so if we look at our original statement, if 2 angles are congruent, this is our hypothesis piece, then they have the same measure, our conclusion. Now, if we were to start with this original statement and have the hypothesis and conclusion, the converse of that original statement means I'm going to switch the order of the hypothesis and the conclusion. So the converse of that original statement looks like this. If 2 angles have the same measure, then they are congruent. So I'm flipping those 2 words, if and then, and that gives me the converse. Okay, so looking at this example, at the bottom, write the converse of each conditional. Determine if the converse is true or false. And if it's false, give a counterexample. Okay, so this first piece, angles that form a linear pair. this is our hypothesis in the original, and they are supplementary. This is our conclusion. So to write the converse, I'm going to start with my conclusion. If angles are complementary, supplementary, not complementary. Then they are a linear pair. Okay, so if you remember from Chapter 2, we learned that supplementary angles are two angles that add up to 180, and a linear pair are two angles that are adjacent, so they are next to each other on the same line, and add to 180. So if I drew some angles that added up to 180, like this, but I did not draw them on the same line, this was 90 and this was 90, those two angles are supplementary, but they are not a linear pair because they are not on the same line. So that means this converse statement is false. And this was my counterexample right here. Okay, let's look at our last one on this page. All squares are rectangles. So if we have all squares as our hypothesis, our rectangles as our conclusion, I'm going to flip those around. So all rectangles are squares. So now I have to see if I can draw an example where it proves that that is not true. So if I can draw a rectangle that is not a square, like this, if I had this side was 10, this side was 5, this rectangle is not a square. So again, that means this statement is false.